Hello students, welcome back to Future Foundation. Students, in this video of circle, we will discuss point of tangency and length of chord. So let's start the video. Write down the heading point of contact or point of tangency. In this we will write a point where tangent meets the circle is called point of contact or point of tangency, right? As we can see in figure, point P is point of tangency. So we have to find the coordinates of point of contact in this article. Now let us consider a circle is x square plus y square is equal to a square, and a line or a tangent which is y is equal to mx plus e times root over 1 plus m square. So if I solve line and tangent, then we will get a quadratic in x, and by putting the discriminant of that quadratic is equal to 0, we can get x. If we get x, then we can get y also by putting in equation of L. So now let's proceed accordingly. So x square plus m square x square plus a square times 1 plus m square minus plus 2mx a times root over 1 plus m square is equal to a square, right? Or x square times 1 plus m square plus 2 em root over 1 plus m square times x plus a square m square is equal to 0. Okay, so by using Shridharacharya, x can be found, which is minus 2am root over 1 plus m square, which is minus b, plus minus root over d, and in this case d is 0 as line is touching the circle. So plus minus 0 on 2a, that is 2 times 1 plus m square. 2 cancel out, so x will become, so in this case x becomes minus m a on root over 1 plus m square, right? Now if we put this x in equation of L, then y is equal to m times minus m a upon root over 1 plus m square plus e times root over 1 plus m square, right? So minus m square a plus e times 1 plus m square upon root over 1 plus m square, which is y. Okay, so y is e upon root over 1 plus m square. So therefore point of tangency or point of contact P is minus m a root over 1 plus m square comma e by root over 1 plus m square. Okay, now let us take a question. Prove that the straight line y is equal to x plus c root 2 touches the circle x square plus y square is equal to c square, and find its point of contact. So students, we need to find point of contact also, and first of all we have to prove that this straight line is touching this given circle. So here c is x square plus y square is equal to c square, and line which is y is equal to x plus c root 2. Now as we know, if a line touches a circle, then perpendicular distance from center is equal to line is equal to the radius, right? So in this case, that tangent is y is equal to x plus c root 2, or this line is this. So if I use this condition of tangency, then mod of 0 minus 0 plus c root 2 by root over 1 plus 1, which is equal to c, which is radius of the circle, right? So c root 2 by root 2 is equal to c, which is true, means c is equal to c. So we can say the given line touches the given circle, hence proved. Now we have to find point of contact also. So from point of contact P, which we have found minus ma root over 1 plus m square comma 8 pi root over 1 plus m square. So in this case P becomes, because in this case m is 1 and a is c, so minus c upon root over 1 plus 1 comma c upon root over 1 plus 1. So point of contact minus c by root 2 comma c by root 2, right? Now let's come to the next topic, which is length of chord. So in this we will write intercepted part of a line from the circle is called chord of the circle. As we can see, this AB is intercepted part of this line from the circle. Let's say this line is y is equal to mx plus c, and this circle is x square plus y square is equal to a square, right? And this AB becomes intercepted part or chord, you can say. So we have to find this length AB. So for this, let circle be x square plus y square is equal to a square, and line be y is equal to mx plus c. If we solve this c and l, then we can get point A and point B. Or if line and circle intersect, then y square x square plus mx plus c whole square is equal to a square, right? And if I expand this, I will get x square plus m square x square plus c square plus 2mxc minus a square is equal to 0, right? X square times 1 plus m square plus 2mxc plus c square minus a square is equal to 0. So if this equation has roots m1 x1 and x2, then x1 plus x2 becomes minus 2mc upon 1 plus m square, and x1 x2 becomes c square minus a square upon 1 plus m square. Now if I find mod of x1 minus x2, then it is nothing but root over x1 plus x2 whole square minus 4x1 x2, and if I put x1 plus x2 and x1 x2 in this radical, then we get 4m square c square upon 1 plus m square whole square minus 4 times c square minus a square upon 1 plus m square. So after taking 4 outside, it will be 2 times root over m square c square minus 1 plus m square times c square minus a square upon 1 plus m square whole square, or 2 upon 1 plus m square times root over m square c square minus c square minus a square plus m square c square minus m square a square, right? So 2 upon 1 plus m square times root over m square c square minus c square plus a square minus m square c square plus m square a square. Okay, so m square c square m square c square cancel out, and this will be 2 upon 1 plus m square times root over e square times 1 plus m square minus c square. This is mod of x1 minus x2, right? Now we have to find mod of y1 minus y2 also, which is mod of mx1 plus c minus mx2 minus c, right? C cancel out, so this is mod of m times x1 minus x2. Okay, so therefore length of chord PQ is root over x1 minus x2 whole square plus y1 minus y2 whole square, as we are assuming here that coordinates of A are x1 comma y1 and coordinates of B are x2 comma y2, right? So this will be length of chord PQ, which is equal to root over x1 minus x2 is, say, x1 minus x2 plus y1 minus y2 is m square times, or m y1 minus y2 whole square is m square times x1 minus x2 whole square, which is x1 minus x2 mod of x1 minus x2 times root over 1 plus m square. And we know what is mod of x1 minus x2, which is 2 upon 1 plus m square times root over a square times 1 plus m square minus c square into root over 1 plus m square, right? So after simplification it will be 2 upon 2 times root over a square times 1 plus m square minus c square upon 1 plus m square. This is PQ, or length of chord, right? Now if we remember this formula for length of chord, then we can directly answer. Let us take a question. Question is, find the length of the chord joining the points in which the straight line upon a plus y upon b is equal to 1 meets the circle x upon a plus y upon b is equal to 1 meets the circle x square plus y square is equal to r square, right? So in this case, circle is x square plus y square is equal to r square, and the line x upon a plus y upon b is equal to 1. X upon a plus y upon b is equal to 1, and circle is x square plus y square is equal to r square, right? Now we have to find this AB. So let us write m, which is slope of the line, which is minus b by a, and c, which is y-intercept. Here we can easily say c is b, and radius, which is a in the formula, and in this case radius is r. So if we use directly the formula for AB, which is 2 times root over a square times 1 plus m square minus c square upon 1 plus m square, then it will be 2 times root over r square times 1 plus p square by a square minus p square on 1 plus p square by a square, right? So it will be 2 times root over r square times a square plus p square minus a square p square upon a square plus p square. So this is AB. So students, let's meet in next video.